Hello and welcome you all in the channel of Smt.R.S.Kalaria YouTube. Here I am Chudasama Priyanka will be enlightening you with the science subject of NCERT 8th standard. The name of the chapter is Materials, Metals and Non-Metals. So let's have a small look at it. You people are aware about what is a metal. Yes, metal means what? That shines and that makes some sound when it falls down. That is what a metal is. And surrounding us there are so many articles which are made with the metals. Now let us have a small look at it. What are the physical properties? Physical properties means what? When you touch something, जब आप किसी को touch करते हैं, किसी भी चीज़ को touch करते हैं, you feel that it is hard. Yes, if it is hard, it is metal. If it break down on falling, it is not a metal. अगर वो टूट जाएगा तो वो नॉन मेटल होगा. अगर वो मेटल है तो वो टूटता नहीं है. It just make the sound when it falls down. So these are few of the physical properties that you are already aware about. But today we will be learning something more and enlightening you with more properties of the metal and non-metal. Let's have a look at this. We are having the physical properties. As I told you that physical properties means what? When you touch something, किसी को भी touch करने के बाद अगर आपको पता चलता है कि वो कैसा substance है, then you will come to know that it is a physical property. So let's have a look at the physical properties of the metals. Here comes the first word, that is malleability. Now what is malleability? When you hammer a metal, किसी भी metal को लेके उसको hammer करेंगे, then it will convert into sheet. You know that. Iron, if you take a piece of the iron and you hammer it continuously, you will see that after some time it will turn into a sheet. What about the gold? The same thing. If you take gold and you hammer it continuously, it will convert into a sheet. Aluminium, you have already seen the aluminium foils also in your houses. Likewise, all the metals when hammered, they will be converting into a sheet. That property is known as malleability. Now let's go and see about the second property, that is called ductility. What is this ductility now? When any metal can be converted into thin wires. Now wires means, if you have seen the gold wires, you must have seen silver, all these wires you must have seen, iron, aluminium, copper, these wires are available to see. So what is this property known as? Ductility means जब उसको हैमर करके हम वायर में कन्वर्ट कर सकते हैं, that is known as ductility. So we have learned two properties here, two physical properties, that is malleability means what? We can convert the metal into thin sheets, that is called malleability. The second one we have studied is ductility. Ductility means what? When any metal can be converted into thin wires is known as ductility. Now let us go with the third property of the metals, that is sonorous. Now what is sonorous? When any metal falls down, suppose in your house vessels fall down, what will happen? Yes, you will feel some sound coming out of that. That is what the property of the metals is. It is called sonorous. When any metal falls down or strike with each other and it makes a sound, this property is known as sonorous property. So here we came with three physical properties of the metal, namely malleability means it can be changed into thin sheets. The second one, that is ductility, means it can be converted into thin wires. The last one, that is sonorous, means it can make the sound when it falls down or strike with each other. So these are the three physical properties that we have studied just now. But before we start with the next session, let's have a look on the activities. It is very interesting activity. Here in our textbook we have 4.1 activity where it is mentioned that these substances when hammered, what will be the result of these things? So let's have a look at that and let us answer them. So we have first iron nail. Now you people can answer me very well that iron nail when hammered, what will happen? Will it flatten or will it be breaking down? So you know the answer. It will be, yes, flattened, of course. So we will be writing F for that. Next metal we are having is coal piece. It is not a metal, we know. So coal piece when hammered, what will happen? It will be flattened or will convert into pieces? Yes, the answer is it will convert into pieces. Next one we have is the aluminium wire. When it is mentioned it is wire means it would be the metal. We know that the properties says like that. So aluminium wire when hammered, again it will be converting into flattened or will be pieces? Yes, you are correct. It is flattened. Next, last one we have is the pencil lead. We know that pencil lead when we are sharpening, what will happen? After some time it will be breaking, means it is not a metal again. Okay, so you can say that it will be converting into pieces. Now second activity, to throw some more light on our topic, we have the activity where we have to identify that the things are good conductor of electricity or not. You people are aware about that. What is the meaning of conductor? Conductor means what? If any substance allow the electricity and heat to pass through them, that is called the conductor. For example, if you have kept a vessel on the gas stove, what will happen after some time if it is on? The vessel will become hot, and if you will touch it, you will feel it is very hot. So you cannot touch it. But if you will hold the handle of the vessel which is made or covered with the plastic, you will feel not hot. Why? Because it is not a conductor, it is an insulator. So you will feel the handles are not hot. So here is the difference between the conductor and the insulator. Now what is conductor? You are aware, anything that allows the heat and electricity to pass through them will be known as the conductor. So let us find out which of the things will be allowing them to have the electricity passing through them. Let's write down for them. Iron rod. You know, iron rod when heated, what will happen? You will feel the other end also of the iron to be hotted or not? Yes, of course hot. So it will be the good conductor. Okay, now second one is the sulfur. You know what is the sulfur? Sulfur is something yellowish powdered form. Now if it is powdered form, it could not be the metal we know, of course. So it will not be a good conductor. So it will be a poor conductor of heat and electricity both. Next we have is the coal piece. Now coal piece, what will happen in this? Coal will be burning. It will not allow the heat to pass through them. They will start burning by themselves. Okay, so we can consider coal piece to be having as poor conductors. Next we are having is copper wire. Now we know that wires are useful in the construction of the houses, and the electricity we are passing through the copper wire only. So here we can say that the copper wire is a good conductor of the electricity. Yes. So here we have came across with two of the activities which tell us complete knowledge about the metals and their physical properties. So by this we sum up, we have a short summary on one of the side of the board that tells us that what are the physical properties of the metal that we have studied until now. Let us go with that. The substance which is hard will be a metal, of course. The substance which shows some lushness means shininess, जो चीज चमकती है, that is lushness. So malleability we have studied just now, means it can be converted into thin sheet. The next one, that is ductile, means what? It can be converted into thin wires. Then we have sonorous, means when it falls down, it will make some sound, that is sonorous. Then good conductors of heat and electricity both. So these are the physical properties will tell us that these substances are metal or non-metal. We have some examples also, copper, iron, aluminium, and so many of these examples we are knowing about. Now on the other hand of this, if we will go with the other hand, we will find the other things are non-metal. Now what are non-metals? The substances which are not hard, means they are soft. They will be known as non-metal. The next one, lustrous, means the substance which are not shining at all will be known as non-metal. The substance which could not be converted into the thin sheets will be, of course, non-metal, means they can break down. So they will be turned into pieces. They will be known as non-metal. On the other hand, we have the ductility. Ductility means what? If it could not be converted into wires, then it is again non-metal, of course. Then we have sonorous. If something falls down and it does not make any sound, means it is again a non-metal. Okay, then we have good conductors and of heat and electricity. On the other hand, we have poor conductors of heat and electricity, means they will not allow the electricity to pass through them. So these substances are non-metal. Can we have the examples of that? Yes, of course. Plastic, wood, all these things are the examples that they do not conduct the electricity or pass through them. The examples we are having now is copper is the metal, but instead of that, if you will find the non-metals, then it is plastic, wood, all these things will be sulfur, all these will be considered to be the non-metal. So, we have now some points which we will be recalling from the physical properties. See, physical properties of the metals we have seen now, but we will go through now as the chemical properties also. But before that, let me tell you that everywhere we have some of the exceptions. In metals also we have the exceptions. Now, what are these exceptions? Let me tell you. Sodium and potassium are two metals which are not hard, not lustrous, not having these properties of the metals. So, they are very soft. They are so much soft that they can be cut with the knife also. Yes, you have heard it clearly. They can be cut with the knife very nicely. So, how soft they would be, you can think about them. The another exception in the metals for physical properties we have is mercury. Yes. Mercury is a metal, but still it does not possess one physical property of the metal, that is hardness. It is not hard at all at room temperature. What will happen? At room temperature you have seen that mercuries are in liquid state. Yes, so they are useful in the thermometer you have seen. As soon as it will be heated, it will start raising in the thermometer because it cannot persist the temperature, so it will be rising up. It will have the volume being increased because of the heat. So these are the three exceptions in the metals we have, which will not be possessing the same physical properties of the other metals possess. So here we have again revision of these three metals, that is sodium and potassium. They are the metals but do not possess the hardness as the other metals possess. So they can be cut with the knife, they are so soft. Okay, and the one which is mercury, which is available in the liquid state at room temperature. So it is again an exception in the physical properties of the metal. Now let us look at the chemical properties of the metals and non-metals. So let's go through them. Here we have the first point, that is reaction with oxygen. Now when metals and non-metals will have the reaction with the oxygen, what is their behavior, what is their output? Let us see about them. So when metals, so let's take an example of the magnesium or iron we can have. Now magnesium you have studied already in 7th standard. When you burn the magnesium ribbon, what will happen? All the other substance burn with the yellow flame, whereas magnesium ribbon will be burning with the white bright flame. So it is again a different thing for the magnesium we have. Now after burning of the magnesium ribbon, you can find the ashes which is of white color. That is to be added with the water in that in a petri dish. Now what will happen? When you will mix it, it will be mixed a little bit with the water. Now take this mixture of the water in a dish and add some litmus paper to it, both the litmus paper, red also and blue also. Then we have to find out that what is the reaction and what is the result on the litmus paper. So for our surprise, we will see that the red litmus will be turning into blue litmus, means it is a base solution. It will be showing the basic nature, means the reaction of the metals with the oxide will be resulting into the basic nature. Now let us see about the another example of the metal, that is iron. We have seen that iron gets rusted on and often after the monsoon season goes away. So what will happen? We have to just take the rust, because rust is the oxide of the iron. How? It has already reacted in the environment. It was open in the environment. So what will happen? Oxygen has reacted on the iron piece, even the water, means humidity also has reacted on the iron piece. So it has some chemical reaction being going on with the iron and it has resulted in the rust. So we have to just take the rust of the iron, add to the water and then add the litmus paper on it. again we will find the same result. Means what? We will find that red litmus will be converting into blue litmus, which shows that it is a basic in nature. So we can say that the metals will be showing the reaction with the litmus paper when we are acting with the oxygen. So the oxides of the metal are basic in nature. Now let's go with the non-metal. What is about the non-metal? Let's take an example of the non-metal as sulfur. We know it is yellowish powdered form, that is sulfur. What we will do for heating it, or what we will do to have the reaction with oxygen? We know that in atmosphere we have a lot of oxygen present, but for non-metal, we need to burn them, we need to heat them with the flame. So what will happen? We will do an activity which is shown in our textbook, activity 4.4. So what we will do over here, we have to take the improvised deflagration spoon. We can construct it at the home also, it is available in the labs also. So what we will do, we will take the sulfur in the spoon and then we will heat it or burn it in the spirit lamp. After burning, we know that it is reactive with the heat. So what will happen? It will melt and will convert into liquid form. But after that, when it is heated, it will give away the blue flame. So we have to just take it and keep it in the cylinder, that is a glass jar. We have to cover it completely so that the smoke does not go out of the glass jar. After some time, when the flame is completely off or extinguished, we have to add some water to this smoke. Okay, so adding water to the smoke and then just to have the movement in the jar, and we will see that the liquid has mixed with the smoke, and thus we will get the sulfurous acid. So this sulfurous acid will be, now we will be able to test this sulfurous acid. So what we will do, again take the sulfurous acid in the petri dish and add the red and blue litmus simultaneously on this liquid. For our surprise, we will see that what is the change in the color. We will find that blue litmus will be converting into red litmus, means the non-metals will be reacting with the oxygen and will be giving the result as acidic nature. So we come to know that the non-metals are acidic in nature when they are reacting with the oxygen. So oxides of non-metals are said to be having acidic in nature. Now let us see the other reactions with the metals and non-metals to see the chemical properties of the metals and non-metals. So the second one we have is reaction with water. The first one we have seen was a reaction with oxygen. Now second one, here we have to see an activity. Now you can see here what is placed over here is a beaker. Inside the beaker I have put some water, and here I have placed a sodium piece which is covered by the cotton. Okay, so what will happen? We know that sodium is very reactive metal. It reacts with oxygen, means air, and water vigorously. Means if you will place the piece of sodium outside in the atmospheric oxygen, or you will place it at room temperature, it will start burning. Or when you will place it in the water, it will burn with a flame. So it is too much vigorous, reactive with the water and air. So it is to be placed in kerosene only, because it will not react with kerosene at all. So it cannot react inside the kerosene, but when it is placed in the water, it will start burning. Yes, this is the one metal or one substance which starts burning when placed in the water. Isn't it surprising? Yes, really it is. So what we will do in this activity, we will take the piece of the sodium and wrap it with the cotton and then place it in the water inside the beaker. For some time you will see that it will start burning with the flame. Now what will happen? After some time you will find nothing placed over there in the water. It means that it has flamed, burned and completely extinguished from the water, means it has evaporated. So the reaction with the water was, it has just turned into the flames and it is no more present in the water now, because it was too much reactive with the water. So this is what the reaction with the water we have of the sodium metal. Now let us talk about the other metals. Suppose we take an example of the iron. What will happen with the iron? You know that when iron is placed in the atmospheric places, what will happen? If it is placed open, it will react with the air or oxygen, and it will be reacting with the water also, but it will have a slow reaction. It will not react so fast as we can see over here. It will react and produce the rust also, but at a slow reaction. It will not react too vigorously. So it can be said that metals react with water and form the oxides of the metals. For example, we have copper. You must have seen the copper vessels at your home. What will happen after some days? When you are filling the water in the copper vessels, you will find some greenish layer is formed at the bottom of the copper vessel. This is again the reaction of the metal with the water. So here we can say that they will be reacting with the water and will be giving us some of the product as the reaction with the water. Now let us talk about the non-metals. What will happen with the non-metals? They can react with the water? Yes, they can react with the water. But what will happen is, for some of the metals, we can say that they will be having no more reaction. Let us see about the phosphorus. Generally, non-metals do not react with the water. But if we will take a look at the phosphorus, phosphorus is the metal which reacts with the air. A lot of oxygen, if it is given, it will react with that. So it has to be cut off from the atmospheric oxygen. For that reason, it is to be placed or kept in the water. It could not react in the water, but it can react with the atmospheric oxygen. So it need to be placed in the water for its security. And sodium is to be kept in the kerosene so that it does not react with the water. By this we conclude that when the metals will be reacting with water, yes, but some metals slow react and some metals will be reacting very fast. We have the examples also. And for the non-metals, generally non-metals don't react with the water. Okay, so we can keep the phosphorus in the water for their security reasons. Now let us see the reaction of acids with the metals and non-metals. Now for that we have taken an example of sulfuric acid. When sulfuric acid reacts with the metals and non-metals, what is the reaction with them? Let us see for that. For that we need to take 5 ml of sulfuric acid with the help of the dropper and place it in the test tube. One by one we will be keeping all these things inside it. So at room temperature we will measure we will see the reaction of the metals, what will happen with the acid, and when we will warm it, we will again see the reaction with that. So here we have first of all is the magnesium. Now what happens when magnesium is placed in the sulfuric acid? We can say that it will not be reacting with it. So we can have that when it reacts with the sulfuric acid, it will be liberating the hydrogen gas, but it will have a slow reaction with it. It will not be reacting faster. But as soon as you will give the warmness to the sulfuric acid solution, when the solution is heated a little bit, you will see that it will react rapidly. So a rapid reaction will be going on. Okay, now next one we have is again the aluminium. Aluminium also again placed in the sulfuric acid will be reacting, slowly it will be reacting and making the hydrogen gas to come out as a reaction and result. But if you will warm it again, it will be again reacting rapidly, means it will be working very fastly. The next one we have is the iron filings, that is iron pieces. Again it will be reacting with the sulfuric acid to give the hydrogen gas as a result. And when it is warm, again it will be reacting faster as compared to when it was reacting in the room temperature. So this is what the difference goes with the warm and the room temperature solutions. Now next one we have is the copper peeled from the wire. Now when this copper will be reacting, it will be liberating again H2, means hydrogen gas, but after slow reactions. But here also it will be liberating it and rapid form. Now let's talk about these non-metals, means charcoal and sulfur. What will happen to these non-metals? Now non-metals will be having no reaction at all with the sulfuric acid, whether it is at room temperature there will be no reaction, or whether it is warm with the heat, then also there will be no more reaction over here. Same with the sulfur, it will not be reacting with the sulfuric acid, so it will be no reaction over here and no reaction in the portion when it is warmed. So this is what we can get as a result. Now let us see about the other example of the acid. Instead of sulfuric acid, let us take the hydrochloric acid as an example and then test it out what will happen to these reactions when we will have with the metals and non-metals. So for that, let's have the HCl, means hydrochloric acid. It is diluted, it is not as it is or concentrated form, it is in dilute form. So as a result, let us find out what will happen in this. Magnesium when added to the HCl, means hydrochloric dilute hydrochloric acid, it will be giving with the hydrogen gas, but will react slowly at that time. But when it is warm, it will be reacting faster, rapidly. The same thing will happen with the aluminum also. Hydrogen will be liberated, but when it is at room temperature, slow reaction, and when it is warm little bit, it will be reacting faster as compared to the room temperature. For iron also the same thing, means metals will be having that HCl we will be having the metals being reacting with the HCl, that is dilute hydrochloric acid, and will be liberating hydrogen gas as an byproduct. But what about the copper? Copper will not be reacting with the hydrochloric acid, so there will be no reaction with the hydrochloric acid we have. So it is non-reactive over here. So it will be giving no hydrogen gas as the byproduct. So copper will not be reacting with the hydrochloric acid. Now let's go with the charcoal and sulfur. What will happen to it? Again the same thing, they could not react with the acid so far. So what will happen? They will also not reacting whether it is room temperature or whether the test tube is warmed a little bit. So there will be no reactions being shown by any of these non-metals. So this is what the reaction goes. Now if we want to test that whether we have got the metal reacting with the acids is correct or not, what we can do is, near the test tube we have to just take the flame of the matchstick near to it, close to it. Suppose this is our test tube and we have the hydrochloric acid or sulfuric acid that is in dilute form over here, and we have added the metal over here and they are reacting. Now what is the reaction? The gas will be liberated from top of the test tube. So what we have to do is, we have to just bring a matchstick over here which is lighted. So what will happen? It is flamed matchstick. Now you will see that, for your surprise, when it is close to the test tube, mouth of the test tube, it will be stop burning, means it will be extinguished, but it will be making a pop sound. Now this pop sound indicates that hydrogen gas is being liberated from this reaction. So this matchstick which was lighted will be extinguished as soon as you will bring it close to the mouth of the test tube. Thus we finished with this point, that acids reaction with the metals and non-metals